This is a presentation of Chapter 6.3 in CCNA1, which is about routers. When we look at the routers, they may look differently, have different design, have different types of interfaces that they have. But when we look into them, we will see that the router is a computer, a very specialized computer. If you look into the motherboard, we will see that inside the router has a CPU like a computer has, and it has an operating system, which is the Cisco IOS that we have been working with earlier on. The router does not have a hard drive as a computer has. It has different types of built-in memory. For instance, we have the RAM, which is a volatile type of memory, which means that it will be emptied when we power off the device. Inside the RAM, we have the running operating system, we have the running configuration file, we have the routing table, the op table, and different buffers. We also have a ROM, which is also which is a non-volatile type of memory. It's a very small sized memory. This is where the Bootup instructions are saved, and also some basic diagnostics and a very, very limited operating system, which just makes us available of starting the device up. We have the NVRAM, which is also non-volatile, which will keep the information when we power off the device. Here we will find the startup configuration file. And then we have the flash, which is also non-volatile, where we save the operating system and other system files. So if we open up the device and look into it, we will see that we have the power supply, which is number 1 here. We have the different slots for the WAN interface cards. We have a fan over here. We have the SDRAM. We have the NVRAM over here. We have the CPU, which is number 6 here. And then we have different integration models over here. So we can actually identify the different hardware when we look into the device. If we look at the external, which we normally will do, we will see on the backplane of the device, which is the front to us when we look in the lab, we will see the different slots for the different interfaces. We will see the AUX port, we will see the console port, which is always labeled blue. There might be some USB, there are some LAN interfaces, which is typically labeled yellow. In the lab, we have 2 serial interfaces also that has been connected, and there are some empty slots where we can put in more devices, because the routers we have in the lab are modular routers, which means that we can put in and put out different slots. If we need more interfaces, we can just buy interface slots and put them in and install them. Yeah, so there could be other ways of looking at this. Is another type where it looks a little bit different, but it also has some built-in slots over here, where we have different WAN interfaces. You will always see there are labels on top of them. So you will see that this is some serial slots. And here again, we have the LAN, and we have the AUX, and we have the console and the USB also in this case. Here also serial interfaces and the LAN interfaces. These are where you configure the router with different IP addresses, for instance. This is the important interfaces to configure when we set up the router. And depending on how many networks you want to connect to, you have a different number of interfaces. Either, well, in real life, you will typically have LAN interfaces, which also could be used for WAN connections. In the lab, we have serial interfaces as well, because this is a good way of emulating something that is slower than a local area network interface. So when we are going to work with different routing protocols, we will see that the serial interfaces are much slower, which typically our WAN interfaces will be in real life as well. We have been looking a little bit at the Cisco IOS. For routers, there are different things we need to configure. For instance, the addressing, the IP addressing. We need to configure the interfaces, the type of routing, whether we will use what kind of routing protocol we will use, some security issues, quality of service, and some type of resource management to keep track of, for instance, how much CPU we are using and so on. When we look at the booting up and the bootset files, well, then they are saved in flash memory. The operating system is saved in the flash, and it will be loaded when we start up. And the startup configuration, if it exists, it will be saved in NVRAM, and it will also be loaded. But first we load the iOS, and then we load the startup configuration file. And this is what it will go through when it starts up. When the router starts up, it starts in ROM, the very small memory, where the router will perform a power on self-test, just to check that all the hardware is answering. Then it has a bootstrap sequence that it will load. And after that, it will go and, depending on how it's been configured, but by default, it will look into the flash RAM and see if there is a network operating system present. If not, it will go to see if there is a TFTP server available on the network where we might have some operating system as well. Then it will go on and look for configuration files. It will start by looking into the NVRAM. If it's present there, then it will go and look if we have a TFTP server, and then in the end it will go to the console and start typically the configuration dialog, which I've always told you in the lab to say no to. This is just like a small setup wizard that will get you through the basic configuration, but we don't want to do that. We want to configure it ourselves. So this is the boot up process. We can change that if I want the server or the router always to start up looking in TFTP server first for the operating system, well, then I can change the boot up sequence. But this is how it looks like by default. And we can see all these things, and we can see a lot of information about the hardware when we do a show version in the routers. It will tell us the processor, how many interfaces that we have, how many and how much RAM we have available, and the last reload also. So there are a lot of information we can see from the show version command. And that was it. That was this chapter. Now I need to close